Alright guys, we're on the second page, still question 1, but the second page of the November 2018 South African Syllabus CAPS Mathematics Exams Paper 2. Alright, so this is still part of the statistics question of question 1, and let's see what we have. So it reads, Reggie works part-time as a waiter at a local restaurant, and the amount of money in rands he made in tips over a 15-day period are given below. So this is the tips each day, 35 on that day, 70 on another day, etc. Question 12.1. 12.1. Calculate the mean of the data. So what is the mean? So let's just say the mean, and the x bar, x with a little bar on top, that's the symbol for mean. That is the sum of all the different values added together divided by the number of values there are. Okay, so that means we have to sum all of this. So if we add up all of that, I've done this just before I started the video. I actually counted up everything. So that is 1420, 1420, and we see there are 15 days, right? They tell us that 15 days, and then we need to calculate that. Let me open my calculator. So 1420 divided by 15 give us 94.67. We have to round off to 2 decimal places because it's money, right? So 94.67. And what are the units? The units are in rands. All right. Now, that was question A. Pretty straightforward. We all know how to calculate an average. B, the standard deviation of the data. Now, we see here this is only 2 marks. But the formula for calculating the standard deviation is actually a lot of work. So what this suggests to me is you should be able to just use the calculator's built-in function for finding the standard deviation. Now, in your calculator, I'm not going to go through the steps of that, but you should be able to do that, or you should be able to find some videos on the internet of how to do that. Basically, you go to your statistics function, and you just enter all the data, and then you look when you go back in for this symbol. That's the standard deviation. So if you press that, it'll give you a standard deviation after you've just entered all the data. But what I'm going to do is I'm just going to show you what the formula is. So we're going to slowly, not too slow, I'm not going to do everything, but we're going to go through the basic idea. So I'm just going to draw a couple of columns here to give you the basic idea of what we're working with. Okay, now I'm not going to draw all the columns. So what we have here, let's call this our xi, so that's the actual values. This we'll call x bar, that's our average or mean. Now we want to do xi minus x bar, so the difference between these two, and then we want to square that answer. Right, xi minus x bar squared. Right, so the formula, let me show you what the formula is for the standard deviation. So the standard deviation is the sum of the difference between the x value or each value and the mean squared. So you sum all of that divided by the total number of values, n, that's an n, how does it look like an n? That's an n, and you take the square root of that. So this is the formula for calculating the standard deviation. So what it would look like if you didn't have a calculator that could do all this for you, you would actually have to work this out. And that's what we used to do when we were at school still. Alright, so we put in all the values, so the first value 35, and then 70, 75, etc. You put in all the values. Then you put down the mean. So the mean is 94.67. So the mean is 94.67 everywhere. So you just put that down. Now the difference between the two, so you take this minus that. Doesn't really matter which way around you minus because we're going to square it anyway. So if it's a negative, it'll just fall away. So you just put in what this value is. So what is this value? 59.67, right? With a negative actually. But like I said, that doesn't really matter. And you do the same for all of them. Just take the difference between these two values. And then you want to square it. So what is 59.67 squared? Let's actually just do that one. 59.67, and we square that. We get 3. Wait, actually, let's first check if 59.67 is correct. So 35 minus 94.67. 59.67. Okay, that's right. And then we want to square that. So 3560. 3560.5089. 5089. Okay, and then you do the same for all of these. You square all of these values to get this column. So that's this column, right? xi minus x bar squared. And then we say we sum all of that. So we find the total here, which I believe was 7, 2, 3, 3, and 3 recurring. So that's the sum, so that's the top part. And then we want to divide that by n. So our standard deviation is going to be equal to that big calculation we did at the top, divided by 15, and then take the square root. And that should give us 22.69. Let me just see if I remembered this 7233 correctly. If we do the square root, so the square root of 7233.3 recurring, let's put a couple of 3's, over 15, let's see what happens, 21.95. Okay, so that's not exactly right, so it should be something different than 72333, but that's, yeah, whatever this answers, this number is wrong, but it's close to that. You just sum all of this. That's how you calculate the standard deviation. Alright, so hopefully at least now you know how to do it with pen and paper, so you can still do this. Obviously you don't have to use a calculator, but for 2 marks I would suggest not going through all of this process. Right? Too much chance to make a mistake somewhere with a number. Just find out how you do it on the calculator in a couple of steps, and you just press this button and it'll give you your answer of 22.69. Alright, question 12.2. Question 12.2. Let's say Mary also works part-time as a waitress at the same restaurant. And over the same 15-day period, Mary collected the same mean amount, the same average amount in tips as Reggie, but her standard deviation was 14. Okay, so let's just write down here Reggie and Mary and see what the differences are. So the mean was the same, right? Mean was, for both of them was 94.67, 94.67. And then the standard deviation for Reggie was 22.69, 22.69. And the standard deviation for Mary was 14. Okay, so this is the information we have. Okay, now what do they ask? Question A. Using the available information, comment on the total amount in tips that they each collected over the 15-day period. So if they had the same mean, the same average, and they worked for the same number of days, they got the same amount of tips, right? Each worked for 15 days with an average of 94.67. So each of them, let's say Reggie's total, let's actually do this, I just want a better notation. The total for Reggie would be 15 times 94.67, and the total for Mary would also be 15 times 94.67. And both of them would be 1420, right? So they got the same. So that's what you want to say. They got the same. They got the same amount of tips. Same amount, the total amount. So let's write in total because I mean it was part of the question. Same total amount of tips. Okay, so that's what they want to do. They want this word, the same amount of total amount of tips. That's question A. Now question B. Question B. We need to comment on the variation that each of them received in daily tips over this period. So the variation, we've got the standard deviation. Now standard deviation and variation, pretty much the same thing. Variance is just standard deviation squared, right? So it's just this part before you square root it. That's the variance. Variation just means, I mean, standard deviation is a form of variation. Variance is another form. So both of these just tell you how far it deviates from an average, on average, right? So if we look at a scatter plot, for instance, if we have this idea, I mean, if you draw a line average, that's a very good line. It doesn't deviate much from the average. If you have a scatter plot like this, it could have the same average, but it's very different each day, right? Sometimes much bigger, sometimes much lower. So this is a smaller standard deviation, this is a bigger standard deviation. So that's the idea. And all they want us to tell them is pretty much for 1 mark which one had a bigger variation, right? So we see Reggie had a bigger variation. So that's all they want us to say for 1 mark. Reggie had a bigger or larger variation. Then we just want to write full sentence. Variation of tips received per each day, right? So some days you got a lot, some days you got very little. Mary, on the other hand, got pretty close to the same amount every day, or at least closer than Reggie. So it's just a 14 difference. So if we drew a scatter plot for both of them, Reggie, we can actually draw Reggie's one, right? So on day 1, 35, day 2. So Reggie's would look sort of maybe like that, with a line like that. So some differences there. Mary's would just look a little bit better, right? A little bit closer all at once, a little bit closer to the mark. Smaller standard deviation, bigger standard deviation, because some of the values are farther away from the average. So basically it just says that some days Reggie got a lot more than 94.67, some days he got a lot less. Mary, on the other hand, got closer to 94.67 most days. So I would just want to say Reggie had a bigger variation, or Mary had a smaller variation, or less variation in the tips she received each day. Okay, I hope this was helpful, especially how to calculate the standard deviation without a calculator. And I mean, this is useful when the numbers aren't as ugly, right? If we can maybe, let's just quickly do an example. Finding the standard deviation for, let's say we just have numbers 3, 5, 8, 10, and 12. Okay, so let me just check if this works out to a nice number at least. So it's 8 plus 8 is 16, 26, 38. There are 5 values? Let's go 6 times 8 is 48. Let's add another 10. Okay, so if we want to calculate the average, we need the average first before we can do the standard deviation, right? Standard deviation formula is the sum of the xi minus x bar squared over n, and we take the square root. All right, so x bar, we need to add everything together. 3 plus 5 is 8, plus 8 is 16, plus 10 is 26, plus 10 is 36, plus 12 is 48. 48 over 1, 2, 3, 4, 5, 6. Over 6, so that gives 48 divided by 6 is 8. So that's our mean. Now we want to write down all the values in our columns: 3, 5, 8, 10, 10, and 12. And it doesn't matter which order you do them, obviously. And now the average is just 8 for each one. Obviously the average remains the average. Then we want to find the difference between them. So the difference here is 5. And again, it doesn't matter if you put 5 or negative 5. 5 minus 8, negative 3. 0, 2, 2, and 4, right? And then we want to square that. So square that, it's 25, 9, 0, 4, 4, 16. Want to add up this total, want to sum that. 25 plus 9, 34, 38, 42, plus 16 is 58. Okay, so we have 58 divided by how many things are there? 6. I mean, 6 things, yeah. And we want to take the square root of that. Let's first just simplify a little bit. So that's 29 over 3, and we take the square root. Okay, so the square root of 29 over 3 give us 3.1. 3.1. Okay, so what this means is that this is not really the correct terminology, but on average, each of these points is 3.1 away from the average, right? So how far is 3 away from the average? 3 away from 8 is 5 away, 5 is 3 away, 10 is 2 away, 12 is 4 away, and 10 is also 2 away. So we can say on average is 3.1 away. That's roughly what this means. So how far is each value away from the average on average? Okay, so that's standard deviation. Right, and that is it for question 1 part 2 then. And I'll see you for question 2 next time.